Okay, today I prepare a little bit of a little talk about the Android's new toolkit that I'm going to explain. This one might be very beneficial to those who are working at Android, but also for those who are not doing Android, maybe you can check it out, and maybe you might be interesting in this new adventure that Google have decided to go through. So with all being said, let me, do I have yeah, I can share. Today I prepared this a talk on Jetpack Compose. So I think let's start. And we are start by defining Compose. What is Compose? Then we'll go on, maybe demonstrate some examples and so on. So what is Jetpack Compose really? This is Android's modern toolkit for building native UI. That's basically it. It simplifies and accelerates UI development on Android with less code, powerful tools, and intuitive Kotlin APIs. It is written entirely in Kotlin, and this toolkit was first released on late July 2021. That was its first stable version. And according to Google developers blog post, Android developers blog post, there were already over 2,000 applications in Play Store, including Play Store itself, were using Compose time. During the first release, there were like over 2,000 applications, according to Google. So now we are going to check a little bit like how this framework work a little bit in depth, and then we'll check out some examples. By the way, these are links. Maybe if I get time to share this one, you might try to check these links, so that I included them there. So Compose is a declarative UI framework. It works by conceptually regenerating the entire screen from the scratch, then applying only necessary changes. So one challenge on that, like that regenerating the entire screen, is that it is very expensive in terms of time, computing power, and battery usage. So to reduce this or to reduce the cost, Compose intelligently chooses which parts of the UI needed to be updated at any given time. Now we are going to see an example of that. As you can see here, this is an example of a composable function. By the way, what is a composable function? These are the building blocks, by the way. In Compose, user interface is built by defining a set of composable functions, or to the other languages, other frameworks like React, are what's known as components. So these composable functions just a term that Google uses to describe their components. So this composable function might take in data and emit UI elements. As you can see here, you just define a function. Now we are going to look at this function a little bit closer. From the example above, you might notice the composable annotation at the top here, composable annotation, this one here. This is the one that inform Compose compiler that the function is intended to convert data into UI. So all composable functions, all components must have at composable annotation. In other words, this is the one that differentiate between the normal function that does like up logics and this one that are emitting UI elements. Again, you have seen that the function takes data just like the normal functions. And this means that composable can accept parameters which allow up logic to describe UI. In other words, you can describe your UI by the data that you are passing in. Also, this function displays text in the UI, and it does that by calling text composable function. Composable function emit UI hierarchy by calling other composable functions. So it describes its hierarchy by nesting other composable inside of it. And also the function does not return anything. They don't return anything because they only describes a desired UI widget instead of constructing UI widget. So they only described it instead of constructing it. Now, in many imperative object-oriented UI toolkits, just like the other framework that has been that is there right now, the XML view system, you initialize the UI by instantiating a tree of widget, and this is done by inflating XML layout. So in imperative UI toolkits, each widget maintains its own state, its own internal state, and exposes getters and setters functions that allow logics to interact with widget. But this is a little bit different in declarative approach, where widgets are relatively stateless, so they don't expose getters and setters functions. In fact, in Compose, widgets are not exposed as objects. They are functions, as we saw earlier. So you get to update the UI by calling the same composable with different arguments. This makes it easy to provide state to the architectural patterns such as view models. Then composables are responsible for transforming the current application state into a UI every time the observable data updates. As mentioned before, like in Compose, like the whole screen is regenerated. So, and that is expensive. So what it does, it only looks for the composable functions that their data has been changed, and those are the ones that get updated by default. So the compiler knows, like, and it does that by using the so-called states. So whatever function that its state has been updated, then the compiler calls that composable with a new updated state to and to render that that function. So in Compose, these composable functions are written entirely in Kotlin, so they can be as dynamic as any other Kotlin code. This means you can use if statements to decide if you want to display a particular UI elements or not. You can use loops, or when statements, or switch in Java programming language. So you can use them to control your UI. Like you can see like an example. Now this is that composable functions that you can see. So let's assume like we want to display a list of to greet a list of users and not one user. So we can just add this annotation right here. Then you define just like any just like you define other normal functions in users maybe. So you can see here this function can take in data, let's say list of users, right? This is a list of, I mean, a string, because I didn't define any data. Then you can because these are normal Kotlin functions, like you can loop, you can do the if checks. So let's say we want to display a list of to greet a list of users, so we can use maybe users, and we call a text widget in Compose is just a composable function named text. So for each user, we can say maybe hello, then we call the user has been. So this function, if we call this function to the, and if we run this, we can see that it greets multiple users at the same time. And also in this function, you can maybe check, like you want to greet maybe only user that their names maybe start with an, as you can see here, it's run with multiple users and it greets them all. So you can even control this. Maybe you want to greet this user if maybe the user has, maybe you can say if maybe user dot maybe the first index is equal maybe to A. You want to greet users that's their name start with an A. Then you call this function again. It can skip all of the users that don't start with A in their names, and you can start like this one. As you can see, it skips all those that their names don't start with A, and it runs only who starts with the. So as we said, like this composable, like you can use if statements, you can use loops to switch between and control the flow, or to control the UI widget that you want to display. Are we together there?
Yes.
Okay.
Yes, we are together.
Thank you. So there's these terms here called the recomposition. In an imperative UI model, to change a widget, you call a setter on the widget to change its internal state. But in Compose, you call the composable again with the with new data. So doing so causes the function to be recomposed, and the widget emitted by the functions are redrawn if necessary with new data. The Compose framework will intelligently recompose only the component that changed. And so in Compose, there are this recomposition and there are composition. So those are two terms that are used in Compose. So composition is that initial, when you run the application for the first time, the initial like the compiler renders those widgets. That's called the initial. And as I said earlier, as I mentioned earlier, that's the part where it's very expensive in terms of power, and so that is why it does not do that second. So the other term is recomposition. Recomposition is what nouns that, like, when the app started to run, user started interacted with it. Then maybe he clicked a button, maybe, and that clicking of button causes a state to change, and that after that state changed, the compiler will call that that composable that's read from that state that changed, so that he can render with new data. So by demonstrating this, let's say, like, we have a button click, maybe, right? Let me just call another here. Let's say we have this button clicked. Then we call the button component that's already defined from the Google themselves. So we have this button maybe here, and it has text, maybe it says you have, maybe it says that. So if I run this button, and if I run this one, you can see nothing happens. So I just want to demonstrate how recomposition happens in a compose. Now that we have this button here, this is composition that happens, that our app runs our composable for the first time, right? So if there's changes in the state that is ready by this composable here, button clicked, that might cause this button clicked to be recomposed. And it does that by, we can define maybe a state here. Let's call this count, right? This might be maybe, don't worry about this. I will explain this when we get to the state part. So I will try to show you how the recomposition works. So let's say we have double state of 0, right? So we want, if a user clicks this button, to increment this count here. So we can say count dot value, we increment this one. Then we want to show that incremented number on button. So maybe I can add this one here. So if I run this again, because now this composable read this state called the count, right? Now, whenever a user clicked this button, that will change the count value from 0 to 1, 1 to 2, etc. Depending on the number of button clicks. So by doing that, so Compose intelligently knows that, and it knows that by using the state object, as we defined here by using this mutable state here. These functions only declare a mutable state of the and that's the object compose used to know if the state changes or not. So if we run this right now, okay, sorry, now it shows that because I didn't give the value in this state here. So this actually this what happened here, it shows the instance of state object instead of value. So until and this mutable state has the value property that used it to demonstrate the value of the specific value. So if we run right now this one, and as you can see, whenever I click here, the button starts 1. So what happened here is that compose compiler run this composable, this one button click again, because its value has changed. Its value from the state that it reads has changed. So whenever this, that is the recomposition to happen. So that's what happened in here. So as I mentioned, recomposition is the process of calling composable function again when the input change. When Compose recomposes based on new inputs, it only calls the functions or lambdas that might have changed and skip the rest. So in our case here, if there was others composable here that creates maybe this particular screen, and in that other composable, if the only value that changes this one, that is one that will get recomposed, and the rest will stay as they are. Nothing will happen to them, and it does that to reduce the cost of battery power and those costs that happens with regenerating screen from the scratch. So now we are at managing states in Compose. So states is any value that can change over time. This can happen. This can be maybe showing a snack bar that will occur at certain time, then gone. Maybe liking a post, showing badges, and so on. So those are examples of states in any programming or in any application, whether it's a web application or mobile application. So Compose is the declarative, and as such, the only way to update it is by calling the same composable again with new arguments. These arguments are representation of UI state. So anytime a state is updated, a recomposition takes place. So as a result, things like text field don't update automatically like they do in imperative XML based. A composable has to explicitly be told the new state in order to update accordingly. And we can take a look at that, maybe text input example to demonstrate well that behavior. Let's say we have this function here, say hello, and we want this say hello to take we want it to take inputs from user. So we'll try by doing this. Maybe we have a text field here. We have a text widget. Now this is the text field. It has value. Let's say it's empty string, and it has events that exposes that value. Let's say we pass in an empty lambda here, and let me wrap this in column. So I will come to explain about this column here later. But for now, let's take a look on the behavior of why these don't update themselves. Let's say we call this, say hello composable here. And if I run this application right now, the text field will not update. Like you, even if you issue some inputs in there, as you can see here, if I try to write anything, nothing happens. This happens because this compose does not update by themselves. Like you'll need to tell the compiler, you'll need to tell it by yourself that this value is changing. So by doing that, we are checking at the so-called state. So compose functions can store a single object in a memory using remember composable. What does that mean? If we don't use remember, that function will get lost every time the recomposition happens. But by using remember, this remember here, this is also a composable functions that will hold the value of that state to the composition tree. So a value computed by a value computed by remember is stored in the composition during initial composition. So remember can be used to store both mutable and immutable objects. So you create an observable mutable state using mutable state of functions, and this mutable state is integrated with the compose runtime. So this is what tells the compiler that if there are changes in the value of the state, as you can see here, it has a value property here, and this also takes behavior from the state object. So by calling these functions, we are instantiating this mutable state here, and we can do. And there are some there are like 3 types of declaring states in compose. The first one is as I demonstrated in the previous example. So now let's make this this composable update its value and also allows us to type some things in, and we are doing that by calling the composable by instantiating a state. Maybe this state let's call it value, and so the other time in the previous example I used the echo to declare a state. But you can declare state by using this by keyword here. This by keyword is just a Kotlin delegation property. It delegates the value of the mutable state to be the value, and to type to be the type of the value property. So you can say remember. You can say remember mutable state of. So the value in this constructor here, the value in this bracket here, the type of this value will be delegated by this keyword. So this value will be the type of this, in our case, string. So we will not have to call the value on the state later on as we did before, because the type will now be string. So now we are making this value to be our state, and whatever initial states that we have, in our case, an empty string, right? And then we will have to check this. I mean, these are events. These are events. So we are changing our events by using these functions here. This is just it's just a function that takes in string and return nothing. So these functions here only changes the value of this state to be the current value that we are putting in our text field. So we are doing that by using, and as you can see, this gives us a string by using the it keyword here. So this is just a Kotlin thing that if you don't give the value by yourself, or if you don't give this value by yourself, which means it will give us state. Yeah, it will give us it keyword. So we can use this it, or we can make it more readable for ourselves by writing maybe, let's say, value. This only makes it be readable. So we can use this value to be our so in my case, I will leave it as. So we say that our value state to be type that we are taking in these functions by using this it here. So by doing this, we'll do this will tell the function that, okay, I have the state now, I have this input, so we want that input to we set that input to be the value of our state, so that it can show to the text feed. And maybe like we can say, like, we want to display that value in our composable. So if we run this right now, leaving anyone behind?
No, I think everything is good.
So now that we run this, sorry a little bit. I think now that we run this, as you can see, now our text input updates according to the text that we are entering there. So without telling without giving explicitly value, and without giving this events here that changes the state, that won't be, our text field will not be updated. So our text field updates only by using this state here that initially start at empty string, and as we go, as we put in some text, then we give that text value to our value state here. So this state now will be whatever value that gets in via that state on value change. Now, so Compose does not limit us to only use mutable state. So for those who are working with Android, they can know this observable types like live data, flow, or RX Java. So these are observable types, and we can even use them to control our state. But before reading another observable type in Java, in Jetpack Compose, you must convert it to be a state. So we are doing that by calling the extension functions. Like for live data, we will call maybe observable as state to that variable. Like we have maybe we have a variable that is a type of live data. So to use that as our state, we'll have to call observable as state that will transform our live data to be this type here, our state type. And for flow, we can use the extension function called the collector state that will change the flow type to be a state. And for RxJava, we can use subscribe as state, and this will also change this RxJava type to be our state. So that with that being said, is that Jetpack Compose only observe the state type. So whenever the state type changes, it will issue recomposition. So in order to work with those live data flow and RxJava, we'll have to change them to be of type state. And we are doing so by calling these appropriate extension functions. Now we are going to the layout. We have discussed about the state, about the recomposition. Now we will check on how to build a UI in a composable or in Compose in general. So composable functions are the basic building blocks of Compose. These are equivalent to the view systems in the view systems XMLs. So this function is a meeting unit that describes some parts of your UI. And the function takes some inputs, might take some inputs and generates what's shown on screen. So composable functions might emit several UI elements, which means that you can nest it and do whatever you want. So however, if you don't provide guidance on how they should be arranged, Compose might arrange the element in a way you don't like. And for that, we can demonstrate that behavior by calling maybe function, let's say user card. So if we say we have like 3 texts, and we have another text maybe. So if we run this, our composable now, sorry, before I run this, I wanna show you a little bit. If we run this, we can see, we don't even see what's going on here because everything is on top of each other. We can't see it because we are not arranging them properly. So by default, Compose doesn't know like what are you trying to do, what are you trying to show. So they will just show one on top of the other. So in order to arrange this, Compose provide a collection of ready-to-use layouts to help you arrange your UI elements and make it to define, and also helps you to define your own. Sorry, I think I made a mistake here. But we can use those elements to those layouts to arrange your element, and those will also help you to define your own layouts. So the standard layout components are as follow. We have a column. This is used to place items vertically. And as we saw the example earlier in this say hello content, that we wrap everything in column. Like by doing this will arrange everything on top of the other. And also there is row. This used to place items horizontally. I mean, one next to each other. And there is a box. This used to display items on top of each other. It's kind of behavior that we saw earlier. That's box behavior by default. So with box, it also supports configuring specific alignment of items in containing in its containers. So we can check. As you can see now, we arranged these things on top of each other. Like we have hello, we have how are you. So right now we have arranged our UI element to display one on top of the other. Now we can use maybe row and this will arrange our elements one next to the other. As we can see here, well, they are near each other. And box is the kind of its behavior like we displayed earlier. So often these building blocks are what you need. You can write your own composable function to combine with this into more elaborate layout that suits your application. So we have modifiers. Also, you can set children position within a row by using horizontal arrangement property in the row. Like we can set maybe horizontal arrangement, and we can make whatever we want. We want our property to align. Let's say we want to add some space. So this will be, maybe we have to put space around, maybe. Yeah. Space around or space between or space evenly, whatever layout we might want. And we can make maybe we can make alignment within a box. We can align items within a box. Maybe by default in the row, items start at the top. So we can set our alignment by calling vertical alignment, and we can say maybe at the top, at the bottom, or at the center. But more oftenly, you will want to align them the center vertical. But there are some cases you might want element within a row to be at the bottom. And also with
Sorry, Tana, you have 1 minute.
I have 1 minute.
If you can at least finalize, or if you want to do another session.
Now, okay, let me finalize. So we have modifiers. These allows us to decorate our composables. So modifiers lets us change the composable size, layout behavior, and appearance. We can add some additional information like accessibility labels. We can process user inputs. We can add higher level interaction like making an element clickable, scrollable, and draggable. And modifier standard Kotlin object. So you create a modifier by calling one of modifier class functions. So and the order of modifier function is significant since each function makes changes to the modifier returned by the previous functions. The sequence affects the final result. So this was the last part, which I wanted to demonstrate a little bit so that you can get an overview of how you can combine layout and these modifiers to get get a layout that you desire for your application. So if maybe you can give me like 10 minutes or less, if that's possible. But here is this was
Let's
the
ask
final
the
part. Yes.
participant if they will give you, or is it that long? Because you can do another session because we still have.
It's not long. It's just a thing at 5 minutes or 6 minute thing. But
Okay, let's
this
hear
was
from
the
them.
last. This was the last part.
Okay, maybe your opinion, guys. Maybe from 3 guys. Should we continue or we do another session? We should be quick.
Let him finish.
I finish. Okay, another one. You guys, are you on your computer or you left it?
We can give him 5 minutes so he can finish.
So continue, Tana.
Okay, so this was the final part, the way I wanted to demonstrate, like showing how you can combine these layouts and these modifiers to get a desired. So in that regard, I will use this. Let's I will have, and within a card, maybe I want to display like row and columns. So I will start with row, where I want maybe to. So I will go a little bit faster. Let's say we have a column here that will show us text fields. Maybe name. Now we can use a modifier here. This one here. Dot maybe height of 4. So if we run this now, as you can see, things are not a bit okay, but now we can use modifiers to decorate this block of code, so that it can look a little, it can be appealed. So let's say we will add a modifier. Let me copy this one. Let's we can control the size of the image, maybe the first thing to do, by saying maybe modify to be modify, but right now we want to check sizes. So there are chains of functions that can combine it together to give us the look that we want. Maybe let's say we want it to be 50 dp, and we want maybe to clip this one to be rounded. And then maybe we want this card to take the entire width of the screen, by saying this one to fill a maximum width. And maybe we can add let me copy this again. we can add maybe padding into this inner box, so that maybe you can take horizontal padding of 16 dp and vertical maybe 8 dp. So if we take a look right now, we might see something a little bit different from the from before. As you can see here, it's a little bit of, I don't know if you see the card here very well, but this is something you can use modifier for. Like you can arrange, you can arrange your element, how your elements maybe look, and yeah, too many of that. Let's say we want this to be part to be width of maybe 12.pp. Actually, I don't need this. So now, as you can see, so you can add these elements, these modifiers to maybe clickable, that will allow this element, like the entire card, to be clicked, or if you want this or to be clicked, this image to be clicked, or if you want the app text to be clicked. So you can add all those modifiers to that will give you that. With that being said, that's it for today.